You know, it's crazy to think about, but like 80% of the data generated in the world today is just completely invisible to a standard Excel spreadsheet.
Right, yeah. And yet, I mean, businesses are out here making trillion-dollar decisions based on that exact information.
Exactly. So today we are jumping into another exploration into the source material, and we want to welcome you, the learner, to today's breakdown. We're looking at this really comprehensive recorded masterclass on the foundations of data analytics.
Which is such a massive topic.
Mhm.
But our mission today is really to just shortcut you straight to the aha moments of what was basically a 2-month intensive course.
Yeah, we want to give you the ultimate primer on how raw information actually becomes, business gold.
Yeah.
And we're going to do it without making you feel completely overwhelmed.
Right, because that transformation, it requires a massive conceptual shift. The core premise from the instructor it isn't just about learning a specific software like Tableau or whatever.
No, it's much deeper than that.
Yeah, it's about realizing that data analytics is really the rigorous eradication of guesswork. You can't just say, I think we should do this, or, dump raw numbers into a model and hope it gives you a magical insight.
Right.
It has to be aggressively processed.
Okay, let's unpack this a bit, because the instructor mentions that data is the new oil, right? So if data is the oil, does that make the data analyst like the refinery?
Oh, absolutely. That's a perfect way to look at it. Because just like oil, raw data is completely useless until it's processed and refined.
So to refine that oil, you need a highly specific methodology, and the source breaks down this strict sequence, what they call the 4 pillars of analysis.
Yeah, and it's a sequential journey. You're moving from just looking at the past all the way to actively changing the future. So the first step is descriptive analysis.
Which is basically asking what happened.
Exactly. Like pulling last month's historical sales data to see which product generated the most revenue.
But that's just the surface level, right? Like, okay, sales went down, but it doesn't tell me why.
Right, which forces you into the second pillar, which is diagnostic analysis.
Yeah. Okay.
You know the sales tanked, but the diagnostic phase investigates why it happened.
Like finding out the app's user experience has a glitch or something.
Yeah, exactly. Maybe an API checkout error caused a 40% cart abandonment rate. You've answered the why. And once you have that causality, the methodology shifts to the third pillar, predictive analysis.
Which is asking what will happen next, using that historical data to forecast.
Right. Like using statistical models to predict Bitcoin's price in 24 hours, or, forecasting next quarter's revenue based on past seasonal trends.
Okay, but the final pillar, prescriptive analysis, that seems to be the ultimate goal here.
It is the holy grail. It asks, what should we do? It's where the analyst provides fact-based recommendations to stakeholders, like, increasing stock of a specific product before a holiday.
So if I'm thinking about this like a medical analogy, right? If descriptive is just taking my temperature and diagnostic is telling me I have a bacterial infection, then prescriptive is the doctor actually handing me a prescription, right? Like they don't just guess the medicine, they base it entirely on the tests.
Yes, that is exactly how the instructor framed it. Analysts never operate on guesswork. A prescriptive action has to be mathematically defensible.
Okay, but getting to that prescriptive stage assumes the data is actually, cooperating. How do analysts find those initial diagnostic clues when they're actually looking at the data?
Well, the masterclass dives into this concept of exploratory data analysis, or EODA.
Right.
It's basically a statistical technique for discovering patterns and seasonality. And it starts with univariate analysis, just analyzing one column, like a frequency of a single event.
But that doesn't tell the whole story, does it?
No, not at all. That's why you move to bivariate analysis, which compares 2 columns, like plotting products against revenue. And then there's multivariate, comparing 3 or more.
Like looking at gender versus revenue versus payment method all at once.
Exactly. It reveals all these hidden correlations you'd never see otherwise.
So that makes sense for numbers. But what about when it applies to real-world communication? Because there's this fascinating segment in the source about a student who is pivoting from mass communications into brand analytics.
Yeah, and they were dealing with sentiment analysis.
Right.
Which is how analysts gauge customer emotion, like positive, negative, or neutral feelings toward a brand, usually using tools like Python.
Okay, here is where it gets really interesting to me. They talked about scraping versus crawling to get this data.
Right, yeah. Analysts generally get this data by web crawling, which is extracting highly specific data, like pulling exactly 1,000 comments from a specific Facebook ad.
As opposed to web scraping.
Right, scraping just extracts the entire website's content indiscriminately, which is way too messy.
But wait, let me push back on this. Why do we need to learn Python for this? Can't we just feed a URL to an AI assistant and ask it to read the comments and tell us the sentiment?
It's a great question, and the source actually addresses this modern dilemma explicitly. You totally can use an AI agentic web crawler, but for massive data sets, like over 1 million records,
It just breaks down.
it's incredibly time-consuming and expensive. And more importantly, large language models are prone to hallucinations. They might flag sarcastic praise as negative sentiment.
Oh, that makes sense.
Yeah, so a deterministic Python script is just far more reliable for that kind of advanced, large-scale analysis.
Which brings us to the actual raw material, the formats the data takes. We mentioned earlier that 80% of the world's data is unstructured.
Yeah, an absolutely staggering amount.
Unstructured data is just images, video, audio, raw text, taking a screenshot of campaign metrics, and that's exactly the kind of data used to train AI models.
Right, but then you have semi-structured data. It's not quite a table, but it isn't just a random image either.
Like HTML for websites, right?
Yeah, or JSON files, which programmers use. JSON features these things called key-value pairs. It's like a dictionary where the key is, say, apples, and the value is 7.
Okay, so then the third format is structured data, the bread and butter of the data analyst. Tabular data perfectly organized into rows and columns, like Excel spreadsheets or SQL databases.
Exactly.
So if structured data is a perfectly organized filing cabinet, and unstructured data is just a giant messy pile of Polaroids and cassette tapes on the floor,
I love that analogy.
which one will you, the listener, actually work with the most?
Well, the reality is that 99% of a data analyst's typical workflow focuses heavily on structured data. You spend your life in those rows and columns.
Okay, but even within that perfectly organized filing cabinet of structured data, the contents still have to be strictly categorized, right? For a computer to actually understand them.
Yes, and this is where we get into data types. Even in a perfect spreadsheet, the computer needs to know what it's looking at, starting with categorical or qualitative data.
Which is basically text-based data from surveys or interviews.
Right. And within categorical, you have nominal data. Nominal means it cannot be ranked or ordered, like race, location, or gender. As the instructor points out, you cannot objectively say one gender outranks another.
Right, it's just a category.
Exactly. But then you have ordinal data. This does have a clear pecking order or hierarchy, like job titles entry level versus executive, or customer ratings from 1 to 5 stars.
Okay, and then on the flip side, we have numerical or quantitative data, number-based KPIs.
Right, which breaks down into discrete and continuous data. Discrete data means countable, finite values.
And continuous means values that can be measured as fractions or decimals, and they change over time, like temperature, weight, or the price of an item changing across different locations.
You got it. And when you're actually working at Excel or SQL, these take the form of core formats, text or strings, whole numbers or integers, decimals or floats, currency, booleans, which are just true or false, and dates and date times.
Okay, let me challenge you on that last one. If I type, the learner is already a data expert into a cell, that's a text type, obviously.
Sure.
But what if I write 2026-0805? Isn't that just text with some dashes? Why does date need its own whole category?
See, what's fascinating here is that date and date time, which also includes hours, minutes, and seconds, they are highly specific, distinct data types to a computer. They aren't just text strings.
Oh, because the computer needs to do math with them.
Exactly. It carries the underlying logic of chronology. If it's just text, the system can't calculate that August 18th is exactly 7 days after August 11th. It can't account for leap years.
Oh, wow. Yeah, I didn't think about that.
Right. And for discrete data, the instructor uses a perfect example. You can have 2 people living in a house or 10 cars in a driveway, but you can never have half a person or 10 and a half cars.
Right. So treating discrete data like continuous data would totally break your analysis. It's amazing how granular it gets. So just to synthesize our journey today, we really went from understanding that data analysis is the shift from guessing to actually knowing.
Yeah, eradicating that guesswork.
Right. We started with high-level strategies like descriptive and prescriptive analysis and went all the way down to the granular level, like how an analyst looks at a single cell in a spreadsheet and knows if it's an integer or a continuous variable.
And for the listener, whether you are looking to actively pivot your career into brand analytics or you're just trying to make better sense of the metrics in your next team meeting,
Just trying to survive the quarterly review.
Exactly. Just recognizing the basic structure of the information in front of you is your ultimate superpower.
It totally changes how you see the business world. But I want to leave you, the learner, with a final thought to mull over today.
Let's hear it.
We've talked all about how businesses use these rigorous models to analyze your data. But think about the digital footprint you created just today. Every text you sent, every video you liked, every purchase you made.
It's a lot of data.
You are a walking generator of continuous, unstructured, and categorical data. If an analyst or even a personal AI agent were to gather your historical data from today, what future prescriptive actions do you think they would predict for you tomorrow?
That is a wild thing to think about.
Right, something to explore on your own. Until next time.